Hey everyone. Welcome back to the channel. Today, we're diving into a fun and practical DIY project. I'm upgrading my old portable soldering iron battery pack using salvaged vape batteries. Now, I've been using 18,650 batteries for a while to power my TS100 and SH72 soldering irons, but I wanted something more compact, lighter, and efficient, especially for field work. So, I thought, hey, let's build a new battery pack from repurposed vape cells. Let's get started. So the first step? Harvesting the batteries. I cracked open 15 used vape pens and pulled out 15 lithium cells, each one rated around 400 mAh. The plan is to wire them in a 3 serial 5 parallel configuration, which should give me 12V at about 2000 mAh total capacity. I'm reusing an old battery case that originally held AA batteries. It's the perfect compact size, and recycling gear is what we do here, right? I also salvaged a small volt amp meter from my old battery pack. It still works, so I figured, let's reuse it as an external power monitor. I found a 3D printable case for it on printables.com. The model was a bit rough out of the printer, but after a bit of sanding and filing, it fits perfectly. Next, I assembled the external volt amp meter. This will sit between the battery pack and the soldering iron, showing me in real time how much power is being consumed, and how the battery pack is holding up. This little monitor is super helpful when I'm soldering outdoors or on site. I want to know if my pack is running low before it cuts off mid-job. Now I started prepping the battery case, stripping out all unnecessary plastic supports and components to make more room for the new cells. Space is tight, so every bit counts. Then, onto prepping the batteries. Before I even touched the soldering iron, I made sure all the cells had the same voltage. It's really important not to connect lithium cells with big voltage differences. It can be dangerous, and damage the batteries or worse. To play it safe, I discharged all the batteries first, then soldered them in parallel 5 in each group. Afterward, I used a TP4056 charging module to balance and fully charge each group. With the batteries ready, I dropped them into the case and started wiring the 3 parallel packs in series to get my 3's configuration. I also reused a small piece of circuit board from the original battery pack. It's kind of a hack, but it made wiring a bit cleaner, and I used my DIY HDD grinder to modify the board to fit the new setup. Now here's the thing, I didn't have room for a full battery management system inside this case. So instead, I'm charging the battery through the TP4056 modules, one parallel group at a time. It's a bit manual, but it works just fine if you're careful. In the future, I might redesign the case to include a BMS, but for now, this solution is clean, simple, and totally functional. Once everything was connected, batteries, outputs, charging leads, I ended up with a compact 12V 2000 mAh battery pack that can deliver up to 40 amps of current. That's plenty for portable soldering and more. Moment of truth. I plugged in the volt amp meter and then connected my soldering iron. And it worked flawlessly. The iron heats up fast, and the meter shows everything's running as expected. No voltage drops, no overheating, just clean, reliable power. This setup is perfect for portable use, compact, rechargeable, and built entirely from repurposed parts. If you enjoyed this project, hit that like button, subscribe, and don't forget to tap the notification bell so you won't miss my next DIY adventure. Thanks for watching, and I'll see you in the next one.